any other, has to match the geologic column or it's rejected, only because the geologic column's been taught for 180 years now. So surely it's true. No, just because it's been taught 180 years doesn't make it true. But that's the logic the scientists will have. Well, we know the geologic column is established, therefore any carbon dates we get should match that. If they don't, we'll throw them out, and we'll keep testing till we do. They might have to test a sample 5 or 6 times till they get the number they want. Well, how do you know any of them are right then? If you're getting a different number every time, how would you know any of them are right? Radiometric dating would not have been feasible if the geologic column had not been erected first. Ever since William Smith at the beginning of the 19th century, fossils have been and still are the best and most accurate method of dating and correlating the rocks in which they occur. Apart from very modern examples, which really are archaeology, I can think of no cases of radioactive decay used to date fossils. They don't date fossils by carbon dating, they date them by their geologic position. That's how it's done. But here's what happens. Earth's atmosphere is about 100 miles thick. Space shuttle, in order to get free from friction, has to get up about 100 miles to be able outside the air. And, you know, straight up, 100 miles is not that far from here to halfway to Tallahassee, you know. But if you go up, look at the atmosphere, it has very distinct layers to it, which is kind of interesting. It has a heat sink where it gets very, very cold up about 7 or 8 miles up, like 80 or 90 or 100 below zero. But the Earth's atmosphere contains mostly nitrogen, 78% nitrogen, 20%, 21% oxygen, a little bit of CO2 for plants to breathe. Well, these don't breathe it, they're fake, but plants breathe in carbon dioxide. And there's a very tiny little bit of radioactive carbon-14, 0.0000765%. This radioactive carbon-14 is different than regular carbon. It's produced by radiation striking the sun, striking the atmosphere. Sunlight strikes the atmosphere, slaps the nitrogen around, and turns it into carbon-14. So it all starts by the sunlight hitting the atmosphere. Just to give you the procedure here, about 21 pounds of carbon-14 is produced every year, and that is spread out all over the world. If I told you there's 21 pounds of gold, but it's spread out equally all over the world, forget it. I'm not even going to go look for it. Okay? You're not going to find it. Real tiny amounts. If you look at a periodic table, carbon and nitrogen are right next to each other. Nitrogen has an atomic weight of 14. Carbon has an atomic weight of 12. But if the sunlight slaps the nitrogen around, it'll knock a few things off of it, and it becomes carbon-14. So it still weighs as much as the nitrogen, but now it's considered a carbon. It's called radioactive, which does not mean it listens to the radio. It's just, it's unstable, and it's going to break apart. It's like 3 guys dating the same girl. That relationship's not going to last, okay, forever. Something will go wrong, right? Find the one you want, Jonathan, and just marry her and be happy the rest of your life, right? Carbon-14 is unstable. It does not like being carbon-14. It wants to get out of this situation, so it breaks down. About half of it will break down on a statistical average. About half of it is going to fall apart every 5,700 years. Now, it is doing this on a purely random procedure. I mean, you got a pile of molecules. You never know which one's going to fall apart. But statistics tell us about half of them will fall apart every 5,700 years, roughly. Now, while it is carbon-14, it's floating around in the atmosphere, like the rest of the carbon, and it latches onto oxygen, like carbon often does, and becomes carbon dioxide. And they hook up, and they're happily floating around the atmosphere. And the plants are breathing in CO2. Animals come along and eat the plants. So the only way carbon-14 gets into the living world is from the atmosphere. It's produced by the sun, striking the atmosphere. Plants breathe it in. Animals eat the plants. Probably during your lifetime, you've either eaten plants or you've eaten animals that have eaten plants. How many have ever done that before? Like today for lunch, right? Okay. Everything we do is from one of those 2 sources. It's plants or it's animals that ate plants. Well, the plants are absorbing CO2. Some of it is radioactive. So if the atmosphere contains 0.0000765%, it is assumed that the plants also have 0.0000765%. Probably a reasonable assumption, and I don't argue with them. I just point out this is one of dozens of assumptions that can enter in to really mess up things like carbon dating. So probably you have 0.0000765% carbon in you, because you've been eating these plants or you've been eating the animals that have eaten the plants. So probably it's all balanced in nature. When the plant or animal dies, it stops eating, stops taking in more C14. It stops breathing. Okay? Now, whatever it had is going to decay. It was decaying while it was alive, but now there's nothing to replace it. So what they do is they compare the amount of C14 in the fossil with the amount in the atmosphere and say, wow, this fossil's only got half as much. Therefore, it's been dead for one half-life, 5,700 years. Because it continues to decay after it died, but now it can't be replaced. So while it was alive, it should have had about 0.0000765%. If it's only got 0.0003825%, it's been dead for one half-life, or two half-lives, or three half-lives, etc. In theory, it never goes to zero. But for practical purposes, you can't measure beyond a certain amount. You know, you're going to run out of stuff to measure. It goes from a half to a fourth to an eighth to a 16th to not enough to measure. A great article came out from Institute for Creation Research. They're the ones that did the RATE project, ICR.org. They said, with their short 5,700-year half-life, no carbon-14 atoms should exist in any carbon older than 250,000 years. It should all be gone. Yet it's proven impossible to find any natural source of carbon below the Ice Age that does not contain significant amounts of carbon-14. Even though such strata are supposed to be millions or billions of years old, conventional carbon-14 laboratories have been aware of this anomaly since the early 80s and have striven to eliminate it and are unable to account for it. Lately, the world's best such laboratory, which has learned during 2 decades of low C14 measurements how not to contaminate specimens externally, under contract to creationists, they confirmed such observations for coal samples and even for a dozen diamonds. I think what that means. The textbooks will tell you coal formed 250 million years ago in the Carboniferous era. And yet when they test coal, it still has carbon-14. How is that possible? If all the carbon-14 atoms would have disappeared in, say, 30, 40, 50,000 years, why would there still be carbon-14 atoms in coal? I got an idea. It's not 250,000 years old. Ooh, boy, they don't like that answer. They'll keep searching until they find another answer because they don't like that one for sure. And diamonds, which they say, formed millions and millions of years ago, they still have carbon-14 in them. And it's not possible to contaminate one of those things. I mean, it's the hardest substance we have. So how do you get carbon-14 in diamonds? And when did diamonds form? Well, I'm not sure when they formed. I know Superman makes them in a few minutes. Take a piece of coal, squeeze it, he's got a diamond to give to, what's their name, but olive oil. And so they've learned today, just in the last 20 years, I guess, how to make diamonds that are just indistinguishable from natural diamonds. High pressure. They've been doing it for years, making artificial diamonds, but they can't get them very big. Now, I think in 2005, they were able to get big diamonds with a synthetic process.
They do it with pets and loved ones.
Take your pet, that's right. Burn the body, cremate it, press right into a diamond. And you can wear your dog the rest of your life, or your ex-wife, or whatever. I don't think I'd want to do that. We were talking about that on the radio yesterday. Anyway, the guy said these diamonds even have carbon-14. It says this cannot be contaminated. Those constitute very strong evidence the Earth is only thousands, not billions of years old. Now, the RATE Project book is difficult reading, heavy reading. Jonathan, you're awful smart. How far did you make it through the book?
About halfway right now.
About halfway, and it's taken you almost a year. Yeah, it's heavy reading. If you want the simplified, don't go down quite so deep version, this one is excellent by Donald DeYoung, Thousands, Not Billions. He kind of summarizes in real English what they said. Different ways to show it. Look, it's not billions of years old. But the carbon dating assumptions need to be pointed out. They'll say, well, we know carbon decays at a certain rate, and so we know if it's only got half as much, it's half as old. There's some assumptions that mess up everything. I'll show you how it works. If I said, we're going to fill a barrel with water. So I hand Leah the hose. Here, Leah, fill this barrel with water. But what you don't know is I have drilled holes in the barrel. While you're putting it in, the water's leaking out. It's kind of like your checkbook. You keep putting it in and it keeps leaking out someplace, right? How many discovered that as you live along? Got the ring, Jonathan? You're discovering now, right? Well, the Earth's atmosphere is kind of like this barrel. It's always getting brand new carbon-14, 21 pounds every year being put in. And it's always leaking out through decay. So the question would be, how long would it take to reach a stage called equilibrium?